Okay, welcome to part 3, year 9. Okay, just a quick question for you straight off the bat. So here is a student that's trying to find the missing side of this green triangle. It's a shorter side. Okay, so she says the missing side of this triangle is 16 because 5 squared minus 3 squared is equal to 16. What mistake has Irene made? Hopefully it's obvious. Okay, here's the answer. Irene has forgotten to square root the 16. Remember, we've got to say that x squared is how you should show your working out. Plus 3 squared equals 5 squared. So x squared equals 5 squared minus 3 squared, which is 16. But to find x, we square root both sides of the equation. So x is actually equal to 4 centimetres. Okay, make sure you show your working out for every single question. Okay. Right, now, consider this question here. If you want to stop the video and have a go at this yourself, please do so. But I'm quite happy for you to just run the video and watch me do it. But this is how we can use Pythagoras to solve some problems where we might not think it's applicable. Okay. Basically, what we're trying to do is find the area of this triangle. And notice it's not a right-angled triangle. Hopefully you can tell me that actually what it is, it's an isosceles triangle. It's an isosceles triangle because these little things here tell me that those two lengths are the same length. So it must be isosceles. Okay. So Pythagoras' theorem doesn't apply directly here, but let's just see what's going to happen. How do I find the area of a triangle? Area is equal to a half times the base times the height. So the half we know, that's obvious. The base is 12. But what's the height? We're not actually told the height here. Remember, that 10 is not the height. That's what we call the slant height. Okay? This is the height. Okay? Now, because this is an isosceles triangle, what I know is that height, h, will cut right down the middle. Okay, it will cut right down the middle. And so what I must have here is a right-angled triangle. And I must know that this side of it is 6 centimetres from here to here. I only know that because it's isosceles. So I know that I'm cutting that triangle in half. Okay? And look what we've got there. We now have a right-angled triangle. Okay? So we can find out what h is. Again, h is a shorter side. So h squared plus 6 squared equals 10 squared. So h squared equals 10 squared minus 6 squared. Using a calculator, I can tell that h squared is 64. So h is the square root of 64, which is 8. Okay, so the height is 8 centimetres. So I can now put that into my calculation for area. So the area of my triangle is a half times 12, which is 6. 6 times 8 is 48 centimetres squared. Must be the entire area of this triangle. Okay? I hope that makes sense to everybody. Let me know if you've got any issues. Here's a bit of an easier question. See if you can find out the height of this triangle to the nearest 0.1, so that's 1 decimal place. Okay, stop your video and have a go. Okay, again, it's isosceles. So when I cut this down here, I get a right angle, and I know this is exactly half. So half of 17.2. Okay, you may need a calculator, but the answer is obviously 8.6 centimetres. So the height squared plus the base squared, is equal to 12.5 squared, the hypotenuse length. Okay, So h squared is equal to 12.5 squared minus 8.6 squared. You're definitely going to use a calculator for that. 12.5 squared minus 8.6 squared equals 82.29. And so h is equal to the square root of that, square root of your answer, equals 9.1 centimetres to 1 decimal place. That's what the question asked for, okay? Now, if I wanted to know the area, I would know that the area of the triangle is a half times the base times the height. And again, calculator, 17.2 times 9.1 times 0.5 is 78.3 centimetres squared to 1 decimal place. Okay, hope that's all making sense. So obviously there's a lot of activities for you to do to consolidate your learning of this. If any